Now we start with our next very important subtopic from the chapter tree in a data structure, that is tree traversal, which is very important topic from the chapter tree, and which most of the times asking for in the gate exam, as well as there are some problems based on this tree traversal. They can ask in examination, in final examination, for sure, almost all the time. So for this tree traversal, for different types of tree traversal that are there in this unit or in this topic, for each tree traversal I will give you some clue, some note, some very important idea, so that you can systematically write down the pre-order traversal, the post-order traversal, as well as the in-order traversal for all types of binary trees. Okay, so let's start. First is the tree traversal. Now, what is tree traversal? Traversing of a binary tree. Traversing a binary tree is a process of visiting each node in a tree exactly once. So again, this is very important part, that is visiting each node in the tree exactly once in a systematic way. Exactly once in a systematic way. It is the definition of tree traversal. Now see here, you you can understand by this term also, as we are traversing from source to the destination, we always think that if there are some attractive points to visit, now we want to cover all, as we wish that we want to cover all, but having some issues regarding the money, we cannot reach over there all the time. Okay, so here also visiting each node in a tree exactly once. So this is our also dream, that exactly once, at least once, we can reach there, we can see this place, or we can see Taj Mahal, or we can see Australia. So this is our wish, that we should visit exactly once and satisfy ourselves by watching this. This is also in the same manner, visiting each node in the tree exactly once in a systematic way. So this is the definition of tree traversal. Now in front of you there is a systematic representation of tree traversal technique. The tree traversal technique mainly categorized into two types, that is depth first traversal and breadth first traversal. Now for the depth first traversal, there are following three traversal technique under the depth first traversal, that is pre-order traversal, in-order traversal and post-order traversal. What are those? Pre-order traversal, in-order traversal and post-order traversal. These are the three main terminologies, the techniques of depth first, depth first traversal from the traversal techniques. Now we start with the first pre-order traversal. For that we consider the algorithm. Okay, I'm first evoking all and then explaining you one by one. Now here I'm inserting the applications for each traversal also. Now here observe the figure and try to understand algorithm also. Now what is the algorithm for pre-order traversal? Is that first of all we have to visit the route. we have to visit the root. Then traverse the left subtree, that is called pre-order left subtree. Then traverse the right subtree, that is called pre-order right subtree. Okay, so that's why what is the rule for pre-order traversal? That is root, then left, and then right. Root, left, right. Root, left, right. Now, as you observe the figure, first we starts from the root, as pre-order technique starts from root, then move to left. Now left is B. To B, the left of the B is D, right? So once left is over, then we are moving to the, once the root is over, then we are moving to the left. Now, next is root E. Okay. Now, after E, we move to the next root, that is C. Now we move to left, that is F, and then we move to right, that is G. Okay, that is root A, then root B, then B ka left, that is D, then B, the right of the B is E, then we move to next root, that is C, then left F, then left G. So this is all about the pre-order traversal. First we visit the root, then left subtree, and then right subtree. Now this is your answer. Now what are the applications of pre-order traversal? Pre-order traversal is used to get prefix expression of an expression tree. Pre-order traversal is used to get prefix expression of an expression tree. This is the application. Pre-order traversal used to create a copy of a tree. Yes, pre-order traversal is used to create a copy of a tree. And pre-order traversal is used to get prefix expression. Now, as we studied what is prefix expression in the chapter 1, so here also in the similar manner we get the prefix expression of the tree with the help of pre-order tree traversal. To traversing the root, then the left subtree, then the right subtree. Now, in order tree traversal, for that we have to consider the algorithm, that is traverse the left subtree, that is called in order, then visit the root, then traverse the right subtree, that is left, root, and right. Now here we have one beautiful node with us. Now what is that node? Okay, now first of all understand again the algorithm, that is traverse the left subtree first. Traverse the left subtree first. So A is the root, left of A is B, B is the root, left of B is D. So we traverse the left subtree. So here we are writing D. Now visit the root for the respective node, that is B. Okay, now traverse the right, then E. Correct? Now, here we are having a node. So keep in mind that node, that keep a plane mirror horizontally at the bottom of the tree and take up projections of all the nodes. Here I am also taking a projection by putting a mirror, and automatically I get the answer. So this is the clue. Automatically we will get the answer of in order traversal. So this is the clue for writing the in order traversal for every binary tree. What is the rule? But we have to visit the left subtree first, then we have to visit the root, then we have to visit the right subtree. This is the algorithm. or we can make a plain mirror in front of the tree and write all the projection, we will get the same result. Now what is the application of in-order traversal? In-order traversal is used to get infix expression of an expression tree. So we are there is a comparison between the expression that we are studied in the first unit, that is stack, and as we are comparing we get the prefix, from this we get the infix, okay, and from the next we get the, I think, the postfix expression. So we will observe that also. So this is very simple, that if we keep a plain mirror horizontally at the bottom of the projection, we got all the in order traversals. For that, what is the rule? First of all, we have to consider the universal rule, and if it is not followed or if we are having any confusion, then apply this technique. Not all the time we are applying this technique, we are focusing all the time on algorithm. It is very important. So we visit the left subtree, then root, and then right subtree. Here also D left subtree, then B root, then E left subtree, then again the A is the root, then left subtree, then root, then right subtree. So this is the in order traversal. Now next is post order traversal of a tree. Now for that also we are having one node which is again very important to understand, the post order traversal. Now for that, what is the algorithm that first we have to understand? Traversal the left subtree, that is called post order, that is left subtree. Then traverse the right subtree, again that is called post order, right subtree. And at the end visit the root, then at the end visit the root, that is left, right, and root. Here also in this example also, we first of all visit the left subtree, that is D, then E right subtree, then root P, then again left F, then G, then C, and after that this is a, right? Now what is the note over here which is important, that plunk all the leftmost nodes one by one. Now what is plunk? Take out. What is plunk? Take out. Okay, now see here. Take out D. Put it here. Okay. Now take out E. Plunk all the leftmost leaf node. Leftmost leaf node. Now again this is very important. Leftmost leaf node. अभी लीफ नोड क्या है, what is the leaf node, that you have to, then that you know. So first leftmost leaf node D, plunk, that is take out. Then next is the E, leaf node. Next leaf node is E, plunk it. Now these all plunk, then the leaf node is B over here, so write that. Now E, next leaf node E, plunk that. Now next leaf node G, plunk that. Now both are plunked, then this is again automatically leaf node C. Then all are plunked, only one is remaining, that is E. So we can use this technique also for take out all the leaf nodes. Now what is the applications, that post order traversal is used to get postfix expressions of all the expression trees. Post order traversal is used to delete the tree. Post order traversal is used to delete the tree. This is because it deletes the children first and then it deletes the parents also. Okay, deletes the children first and then it deletes the parent also. Okay, so this is all about the post order traversal of a tree. So in these three types of binary tree, You have to consider the notes also, and you have to consider the logic, the logic of the tree also. Thank you.